row, 2. Okay, we're going to find how to find the distance between 2 points in the universe. Because you could draw a coordinate plane between any 2 points in the universe, right? So we have a point on this plane at 1, 1. Now I need one more point.
-5, 5.
1, 3.
Tara, what is it?
-2 and 4.
-2, 4. So somewhere up here. So if we wanted to know the distance between these 2 points, we simply could use what we learned yesterday, right? We could take those 2 points and create a
Triangle.
right triangle. And this is not as pretty as it could be, right? Once we have a right triangle, the distance between those 2 points is simply what side of the right triangle?
The big
The
one.
hypotenuse, right?
Hypotenuse, that's what it's called.
Okay, so to find the distance between any 2 points, draw a right triangle. Then what we're going to do is find these legs, right? And use the Pythagorean theorem. Okay, so we want to know the distance that forms this leg. And so how do we find the distance that forms that lower leg there? Now, how do you find this? I mean, here it is on the graph. All you do is say it, Jocelyn. You count. You go 1, 2, 3. Oh, that's a leg of 3. Now, are we moving in the X direction or the Y direction? The X that direction, right? The X.
What are the two?
Wow. I don't think it is though, because when we go this direction here, we're only going 3. But what we're moving there in which direction?
Something.
The Y direction. Okay, so we see that both of these legs are 3. Now we could use the Pythagorean theorem, right? But the Pythagorean theorem is going to look different because we're calling this now the distance formula. So if the Pythagorean theorem says this, a squared plus b squared equals c squared, what would we do to it to get c alone right now? Andrew? That's not going to get c alone. Kelly?
Find the square root.
Take the square root. So we'll take the square root of both sides, which leaves c on its own, and we have the square root of a squared plus b squared. This is the distance formula. Rather than calling c, we call it d for distance. Okay? Rather than calling a, we call it the change in the x, and we call the b the change in the y. So here's your formula. Find the change in the x squared plus the change in the y squared, the 2 legs. When you take their sum and take its square root, you will get the distance. Now, the question comes up, can you just call this a plus b?
Yes.
And the answer is no. Okay? And we could prove that with numbers that we already know. Let's say, if I was taking the square root of, let's say, 9 plus 16, a person who might make that mistake would say, what's the square root of 9? And what's the square root of 16?
4.
So this would equal 7 if that was to work, right? But let's add, what is 9 plus 16?
20.
25, right? What's the square root of 25? 5. So this does not work. You cannot take a root of something that's being added in the radicand. You've got to simplify what is in the radicand with addition. Addition makes life a lot more tricky in algebra. Multiplication and division are usually easier than the addition problem issues, right? Okay, you're asked to find the distance now between these 2 points. So if you have a coordinate plane, you could go and count the legs, right? You could plot this at -3, 1, and at 2, 3. You could draw your little segment, and then you could say, oh, I could draw this in, right? How long is my x leg? How long is my y leg? If you have that opportunity, then the formula isn't even needed so much, right? You can just say, wow, this is a change of 2. Here we have a change of 5. So 5 squared plus 2 squared equals my distance, right? You can just use that. It is the same when you use a distance formula. So let's move this down. The beauty of this formula is you don't have to go graph. You can simply say the distance equals the change in my x squared, the change in my y squared. Who can plug those in for us? Summer.
Oh wait, it's x squared, so it's it's 2 minus 3 plus 2 minus 1.
X's, and now we need y's.
3 minus 1. Sorry. I was looking at the wrong thing.
Okay.
And then we'll say 3.
So look at, when we take 2 minus negative 3, we end up with exactly what we said was the length of one leg, okay? And 3 minus 1 is 4, which is, did we do something wrong? Oh, 3 minus 1 is not 4. I'm jumping ahead to squaring it, right? What is 3 minus 1?
2.
2 squared, which is exactly what we said the other leg was. So when we just find these differences up here, we don't need to graph. We're finding the lengths of our legs of a right triangle. And 25 squared is?
25
squared.
And 2 squared is?
4.
So we end up with the square root of
29.
29. And in this section, we're going to leave our answers in simplest radical form.
So like that.
Could anybody estimate the value, though, of the square root of 29? To the 10th? It's 5.4. Very good. 5.4. Good. Okay, so now the next question. What if you know the distance between 2 points, but you just don't know where a point is? This is a little more challenging. Okay, so here we have a point at 4a. I don't know the y value. And a point at 1,6. But we know that the distance between these points is 5 units. Once again, we start with the formula. And who can substitute the known values into this one now? Jocelyn.
1.
Do we know D?
Oh. 5.
We know D. Good.
Equals
It's 5.
the square root of 1 minus 4 squared plus 6 minus 3 squared.
Good. Okay, so we have a lot going on. We know that we cannot just pull things out of that radical until things in there have been simplified. But when we were solving radical expressions earlier in this chapter, what did we do to simplify a radical expression? Where one side is 5 and the other side has a radical. Remember? We squared it. Very good. So one thing we could do right now to simplify things is square both sides. And on the left, we end up with
1 minus 4 squared plus 6 minus 8
25.
squared. Oh, on the left.
And then on the right, let's go ahead and simplify as we go. What is 1 minus 4? Negative 3 times negative 3 is 9. And then over here we have this thing, this whole binomial being squared, which is going to make this trickier, right?
Yeah.
Now, there are many ways that a person could come to the correct solution here. What is one way? What are you thinking now you could do? Yes?
Well, if you want to set it equal to 0, then you put minus 25. Or if you don't want to set it equal to 0, you put minus 9.
Okay, let's see if we didn't set it equal to 0, let's see what we would do here. This is kind of interesting. We would have 25 minus 9, which is 16, equals this square of a binomial.
Well, couldn't we take the square root?
And then couldn't we take the square root? I feel like we're on a teeter-totter. We're at one point we're squaring square root things, and now we're going back to maybe taking the square root of both sides.
Yeah, you go somewhere.
Which gives you 4 equaling 6 minus a.
And then you
You subtract
six.
6.
If you subtract 6, what's left?
Negative
2,
2.
and then you multiply by a negative.
1, and you end up with 2 equals A. That's right. So the value for A here is at 4, 2. That's the point. So if you can imagine on a coordinate
This is so
plane,
much work.
we have 1, 2, 3, 4, 1, 2. We have a point there. We have a point at 1, 3, 4, 5, 6 up here. So the distance between these points, we're saying, or they told us is 5. And that looks reasonable, doesn't it? We have points that seem to be reasonable. Okay, go ahead and pause and come back and check your answer.
many of them.
So everyone determined that this equals the square root of 181. And then if you need to walk through the second one, you can pause the video. But the values were substituted, both sides of the equation, we took the square root, and we found that A equals 2. Okay, so the second topic, short topic, is a midpoint formula today. Any 2 points, midpoint, can be found just by using the end points, okay? So I think we'll come back up and we'll write the midpoint formula after we go down here and look at a sample.
How many lines?
So you just need probably 3 lines. So let's try this sample and then we'll fill in the rule, okay? So we have the chance to graph these 2 points. -3, -1. Oops, I got a calibration. I'm going to pause this and do it. Okay, so here are the 2 points, -3, -1, and 7, -5. And so how could we find the midpoint of this? I mean, you all know it's going to be kind of in the middle, I mean, by definition, right?
I think I
So,
know.
what do you think, Talia?
Is it the formula divided by 2?
Yes, it is, because we're going to say that the distance in the x direction between -3 and 7, how far would we travel from -3 to 7? How far are you going to travel if you go from the end point -3x to 7? 10. So halfway between would be 5 from either end, right? So if we start at the -3, we would go 3, 4, 5. We'd be at 2, right? We'd be at an x value of 2. X is 2. And in the y direction, we're going from down here at -5 up to this point at -1. How far have we traveled? From -5 to -1. We traveled 4, right? 4 from either point, though. So if we start from the -5, we would go up how many places to get to the middle? What's half of 4? 2, right? So -5 plus 2 is
7.
negative.
I mean, negative 3.
So this is the midpoint formula.
Wait.
What we just did was exactly what Talia said. We divided something by 2, right? These are the 2 midpoints. You simply, look at where we ended up here. We ended up at 2. And look at the values for x, 7 and -3. What would you have to divide by 2 to get to 2? We got to 2. We got to 2.
4.
You'd have to divide 4, right? How can I make 7 and -3 equal 4?
You subtract.
Add them together. 7 plus -3. You simply add the x values of the endpoint, right? And divide by 2. Let's see if that works for the y. If I add -1 plus -5, what do I get? And what is -6 divided by 2? -3. Exactly the midpoint we found. Okay? So midpoints are simply averages of the endpoints. You simply add the x values, divide by 2, and add the endpoints y values and divide by 2. Now what makes this a little tricky is we're adding and dividing by 2. But in the distance formula, we subtract, don't we? So that can be a little point of confusion at times. And there's your assignment.